Can everyone hear me now? Yeah, perfect. Cool. So you guys have heard a lot about intelligent contact center and AI. I've been coming to this conference for a few years now, and I can see like AI is now being talked on more than ever before, and that's not going to stop anytime soon. But we'll share with you our approach to AI in the contact center. So first, just a little bit of a quick fun video. How many here know the game Breakout, have played Breakout before? Most of you? Sorry, you can't hear me? Oh, okay, sorry. Can we turn the volume higher a little bit? Where's the sound control? Okay, working on it. I'll try and talk closer to the mic in the meantime while they're fixing it. Okay, so Breakout has existed since the 70s. It was developed for Atari, and it's been a very popular game. There were also computer algorithms that were built to play the game on behalf of players, right? And the way it works is you have, sorry, how do I do this thing? You can't really see my pointer, can you? You have a bat that follows the ball, and as the ball goes left and right, usually they program the bat to sort of follow the ball around, and that way it hits it and it doesn't lose. We tried to run this experiment a few years ago at DeepMind with machine learning, but we took a very different approach. Instead of teaching the bat how to play, we basically said, try everything. We didn't give it any guidance. All we did was we gave it a way to calculate the score. So what it did was it tried a lot of different things, and it saw what score it's getting, and it tried to improve over time. And you can see when it started out, it wasn't playing very well. You can see it did like funky stuff like that, where it's moving. It's not even moving when the ball is coming, and it didn't really know what to do. But then after 300 games, you can see it actually became pretty good, right? And you can see it's sometimes even moving in the opposite direction of where the ball is, because it's anticipating where the ball is going to be. And no human taught it to do that, right? It just learned by itself. And then after 500 games, suddenly it became an expert in the field. And you can see how it got up to the top there. How awesome is that, right? And this is basically all teaching itself. This is one of those sort of profound moments where we saw the power of machine learning being unleashed, and we understood, for the right type of problems, as long as it's classification or prediction or one of the problems that machine learning is good at solving at, and as long as you have sufficient data, machine learning is always going to be better than any algorithm that we build as humans. So what does that mean? Basically, machine learning and AI can be used for a lot of different things. A lot of the people here in the audience are familiar. Some are kind of newer to the space. But if you think about, getting more revenue in retail by understanding what's happening to your inventory or demand for products, if you think in transportation, of being able to better upkeep your equipment and make sure there's no downtime, or kind of across the board for all the verticals, AI is really useful. So with that, let's take a short break from AI, and I want to talk to you a little bit about Google Cloud, why we're so excited about Google Cloud. And I know a lot of you are not that familiar. People have asked me in the last couple of days a lot of questions about Google Cloud. So just to give you a little bit of an intro about what makes Google Cloud special. So we take a different approach to 4 different problems. So first of all, we have the most secure, reliable infrastructure that's available out there. That's basically, it was born from the infrastructure that was built to run Google, right? Which is compute at a scale that doesn't exist elsewhere in the world. We help you unlock the value of your data with AI and with other types of analytics that are pretty unique in the industry. We provide the freedom of multi-cloud, so we're very open. We let you run your workloads wherever you want, and we help you organize everything so you can get the best job done that works for you. And we have a set of tools that empower developers like Kubernetes, like open source. A few weeks ago at Google Cloud, we introduced Anthos. We'll talk a little bit about that. We also introduced Cloud Run, which brings the power of serverless infrastructure together with Kubernetes and gives you the best of both worlds. So just a little bit about a few of these things, and then we'll come back to AI. So if you ask IT teams at most large companies how their security works, the typical view is it's like a fortress, right? It's very strong from the outside. There are all these tools that protect the corporation, like firewalls, like VPNs, like other tools. And you know, when everything works, it's great, right? But what we've seen over time is this strategy of having kind of a hard shell and a soft belly leaves you vulnerable when someone is able to breach the walls of your gate, right? And what it actually looks like is something like this, right? When you're able to get in. And so rather than taking that kind of approach at Google Cloud, what we're taking is a layered defense system that protects you all through all through your stack. So from the hardware, we have our own proprietary chips that we've developed that help secure our data centers. And we have special hardware that's also available to be secure elements for laptops and for wherever your endpoint devices are. Then it goes through our network, through storage, and through your applications, and we provide tools to secure the whole journey that are built from the tools that we use at Google to secure Google's data, right? And so that's pretty unique in the industry. Let's talk a little bit about data and privacy. So first of all, we believe that you own your own data. Google does not own any cloud customers' data. And you know, we're very strict about that. We have the strictest privacy policy in the industry. Google is the only large cloud company out there that does not use your data to improve Google Cloud's products without your consent, unless you explicitly opt in. We do not use your data to improve the product. This is not true for any other large cloud provider. So it's pretty unique for Google in the industry. We don't sell your data to third parties. We don't use it for advertising. We have very strict privacy policies for data in Google Cloud. Another thing that's kind of pretty differentiated is how we approach the network. So typically, most large cloud providers rely on the public internet, right? So your user needs to go through all of these different hops to basically get to whatever infrastructure you deploy in the cloud. And that adds latency. It also adds a little bit of reliability issues because, as we all know, the public internet usually works, but it's not guaranteed to always work at any moment in time. Google Cloud relies on our own private network backbone that's unique to Google. And it's more reliable and it's faster than anything else that's out there because it doesn't rely on the public internet for transit. So let's talk a little bit about Google as an open cloud. So we just introduced Anthos a few weeks ago. So Anthos, what it does is it allows you to run your workloads through Kubernetes in any system you want. You can run them on Google Cloud. You can run them on-prem. And you can even run them on other clouds. And we'll help you manage your infrastructure and manage your workloads and make sure that everything is running the way you want it to run. And it's all built on open source protocols like Kubernetes, Istio, Knative. It's pretty unique to Google Cloud. No one else lets you do something like that. Okay, back to AI, I promised. So, you know, AI is great and everything, but why come to Google Cloud to do AI, right? So Google is an AI company. You can see on the left, This is the chart of adoption of machine learning at AI, the number of projects that are using Google Brain models. This is sort of what we call our AI research team. And you can see it really skyrocketed a few years ago. And today, all of Google's major products basically rely on machine learning to do multiple different functions. So if you think about Google Search, if you think about Google Assistant and Google Home, even Waymo, which is an Alphabet company, they all rely on machine learning and AI, and it's kind of core to everything we do at Google. And we wanted to bring that out to external customers as well. So the way that we do that is with what we call Cloud AI. And we're doing it in 3 different ways. We're building a platform that lets you run your own custom models with your own data and build models that help you solve whatever problem you want. And that's what we call the platform. We have building blocks that are pre-built machine learning models that we've built at Google Cloud, and they help you solve specific problems without the need to train your own models. And then we have our solutions that are higher level of abstraction components that help you solve business problems. And then digging a little bit deeper, I know this is a little bit of an eye chart, but essentially you have in the bottom layer that platform that I was talking about. You can bring your own data and train your own model and use a lot of the tools that Google engineers use to train their models, right? But of course, you need the right expertise, you need the right data scientists, you need the right data to be able to do that. And then the second layer there is what we call our building blocks, APIs and AutoML. And there we have things like vision, like translation, where rather than build your own translation machine learning model, you can rely on Google's translation engine that powers Google Translate. And they're all available to consume as APIs in the cloud. And then you have sort of our solutions on top, like our talent solution for people that are interested in improving hiring and recruiting. Document Understanding AI we just introduced a few weeks ago. It can help you understand figures in a document and structure them in a way that you can then take advantage of in your logic applications. And then there's these 4 components that we're going to really spend the rest of today talking about. So our conversation building blocks, speech to text, text to speech, and dialog flow, and our business solution, Contact Center AI. So let's start from the top, from Contact Center AI. So we think contact centers are a perfect challenge for AI, right? They're first of all, significant enough to most companies in the world, and then they're not in a great situation today. So first of all, people hate calling IVRs, right? It's a pretty frustrating experience, and people end up just dialing 0 multiple times or shouting representative, representative. We think that's something that AI can really help with a lot. Even talking to an agent, wait times are too long. It's a pretty frustrating experience as well. And we think there's a lot we can do to make agents more productive. And then the other problem that's causing the wait times to be too long is there's actually a talent problem in the industry. And there's a lot of churn, there's a lot of turmoil, and it's actually pretty hard to run a contact center these days. And we think AI can help with understanding insights about the contact center, understanding who are agents that perform better, how you can get more out of your existing contact center. So it can help in all of those different ways. And that's exactly what we aim to do with Contact Center AI, right? So enabling better user experiences, enabling human agents to work faster, and enabling every enterprise out there to be able to understand what's going on in the contact center and transform their business. And we're doing this all with the existing telephony infrastructure and skill sets that are out there. So our approach to AI is quite differentiated from a lot of other companies. We're not asking people to kind of rip out all the infrastructure that was built over the years. Instead, we're actually adding AI into existing contact center infrastructure. And the way we're doing that is with what we call Contact Center AI. It's a combination of 2 things. It's our conversational AI that Google built, and basically we're giving the best of Google Cloud AI in this space. And then we're partnering with the leading players in the contact center field and in telephony. A lot of the players that are represented here in this conference, and we're partnering with them to bring AI to market. So you can, if you're using infrastructure from any of those companies on the right, you can now add Google Cloud AI to your existing contact center pretty easily. Let's see a quick example of how that could look like.
AI-powered customer service experience. Google Cloud and Salesforce are partnering to deliver AI-powered customer service experiences so that every company can transform their customers' experience. Let's show you Hulu's vision for scaling engaging experiences for their more than 25 million subscribers through the eyes of Lauren, a Hulu viewer. Hulu makes it easy for their viewers to get help anytime, anywhere. Instead of customers having to navigate a lengthy phone tree, a Hulu bot powered by Google Cloud's virtual agent technology can immediately engage viewers in a human-like conversational experience, help resolve issues 24/7, and seamlessly hand off the call to a human agent at the right time.
Hi Lauren, thanks for calling Hulu. How can I help you today?
Hi. I want to add the NBA package to my plan.
Sure thing. Looks like you've been watching on a Chromecast Ultra. Is this the device you'd be watching the game on?
Yep.
Perfect, I'd recommend our Hulu Plus Live TV plan. If you'd like, I can transfer you to one of our viewer experience advocates to get that set up.
That would be great. Thanks.
The human agent now has everything they need in the Salesforce Service Cloud console, including the full call transcript to expedite case resolution. Meanwhile, Google's Agent Assist technology automatically presents machine learning-driven recommendations, making it easy for agents to know what viewers need and get answers fast.
Hey Lauren, thanks for calling Hulu. It looks like you'd like to add the Hulu Live TV plan to get access to all of the basketball games. I'd be happy to help you out there.
That would be great.
Perfect. I'll update your plan to add Live TV.
As the call progresses, Agent Assist continues to surface new recommendations based on the context of the conversation.
Did you know that you could also watch Hulu Live TV on mobile devices? Would you like me to help you set that up?
Sure, I'd like that.
Great. I'll send over an article that will walk you through the steps for future devices as well.
Agents can even add more value to every conversation with the intent matching capability from Google Cloud Dialogflow and Salesforce Einstein to serve up the real-time recommendations and offers to keep viewers engaged and happy.
What else have you been watching recently besides basketball?
My husband and I have actually been binge-watching Game of Thrones. We want to get ready for the final season.
Awesome! Did you know that if you add HBO through your Hulu plan, you can watch directly in the Hulu app? If you'd like, I can add HBO to your plan as well.
Yes, let's do it.
Agents are guided step by step through any business process. No memorization of what to do next required. The combined power of Google Cloud AI and Salesforce Einstein also makes call wrap-up easy with pre-populated case details, improving data quality and saving agents time as they move on to helping the next viewer. With Google Cloud and Salesforce, Hulu can now integrate AI into every service interaction and reimagine the viewer experience.
Great. So there was a lot that you saw there. Let's unpack it a little bit. So the first thing you saw were our Dialogflow virtual agents. So you saw that the customer starts by facing an automated experience. And we do think a lot of calls to call centers today can be substituted by virtual agents. But that being said, we know that that's never going to be sort of every single call. And to really create a great user experience, you need to have human agents for those calls that need human assistance. What you can see there is we provided what we call Agent Assist, which surfaces article recommendations based on what topics the conversation is leaning towards. And This may sound trivial to you, but it's actually, we found it to be quite impactful. We've seen examples of when we've analyzed calls to call centers in the industry, we've seen cases where 20+ minute calls could have actually been reduced to 10-minute calls if the agent had the right article in front of them at the right time based on what the customer is saying, right? And so this could significantly help improve agent productivity in call centers. And then last but not least, contact center analytics powered by our topic modeling capabilities. That helps you understand what's going on in your contact center. And we'll see a little bit more about that later on. So just a quick view of how it all works together. So the typical journey of a call could be something like this. It starts by a customer calling the telephony infrastructure provided by one of our partners, and then it goes from there to Google Cloud Speech to Text. Google Cloud Speech to Text turns it into text that is then fed into our session manager. While the call is in sort of the bot mode, it goes to Dialogflow that runs our virtual agent. And then once the virtual agent gets the right answer is fed to Cloud Text to Speech that uses WaveNet to synthesize speech, and we'll talk more about that a little bit later. Then sends it back to the telephony and to the customer. But then at some point, the bot realizes that the call needs to go to a human agent. And what it does is, through the session manager, it transitions the call to the human agent. But it doesn't leave the human agent sort of to deal with everything by itself. But instead, it provides what we call agent assist, that provides assistance to the agent with recommendations. And that is based on our knowledge service that holds all of the knowledge base that's relevant for your business. Then that all gets surfaced in the agent desktop like you saw in the video from Salesforce. And then through the sort of the feedback that comes from the agent, we can actually improve the accuracy of this advice through this feedback loop that goes back into the knowledge service and back into Agent Assist. And then once that call is over, all of the transcript of the call is available for analysis, and that can be fed into topic modeling to kind of understand what are the hot topics that people are calling about today. And every day or every hour, it could be something different depending on your website is down or whatever else is happening. Okay, let's talk a little bit about sort of those three components you saw there that are powering the conversation: speech to text, Dialogflow, and text to speech. So first, Dialogflow. In Google Cloud Next 2017, 2 years ago, we announced that Dialogflow crossed 150,000 developers. We were very thrilled about that. But now, a few weeks ago, in Next 19, we just announced it's crossed 850,000 developers. Let me pause on that for a moment for reflection. So I don't know how many people we have here in the room. 1, 2, 3, 4, 5, 6, 7, 8 tables times 1, 2, 3, 4, 5, 6 rows. So, maybe there's like 500 people here in this room, maybe more. Imagine 1,000 times rooms like this that are all full with developers. Dialogflow is we're very thrilled about the adoption, and we're hoping that it becomes kind of the standard for anyone that wants to build a bot. It's the first question should be, why not do it in Dialogflow, given that everyone else is using Dialogflow? And this is not just sort of long tail adoption that we're seeing. We're seeing strong adoption with enterprises. Many thousands of large enterprise customers are on the platform. There's billions of interactions sent annually. And these are just a few logos. This slide is actually outdated. There's a lot more that we would add if we did it today. But just to give you a sense of, companies like Uniqlo, like CNN, like Domino's, like many others are all using Dialogflow to power their businesses. And why is that? There's a lot of reasons. One is it's much easier to get started. It's very developer friendly. You can build your first bot in a few minutes. or a kind of a more advanced one in a few hours, and put it on a telephony system and run it as an IVR right from our website without needing to do anything else. And you know, it's more versatile. It's available in 14 plus platforms like Facebook Messenger, you know, like telephony and IVRs, like Slack and everything else you want. But the number one reason why people choose Dialogflow is it's just really good at NLU. It understands users better than anyone else. Discover Card did a very extensive benchmark with all of the large providers that are out there, and they found Dialogflow to be the most accurate. They published a blog post, which you can read more about. But we hear this time and time again, that people sort of tried other bot platforms and ended up switching to Dialogflow just because of the accuracy. And you know, sometimes a lot of customers initially think, hey, I don't need the best accuracy. Something that's just accurate enough is good enough for me. But you'll see in a little bit why it actually matters a lot, even if it's just fractions of a percent. Let's switch to talk a little bit about speech. So we started working on speech more than 10 years ago, I think more than 15 years ago at Google. And we built it initially for our consumer products, so voice search, like navigation in Google Maps with both speech recognition and speech synthesis. And then captions for YouTube that are generated automatically. Or now with Google Assistant and Google Home, it's powering a lot of our consumer experiences. What makes speech special at Google is we have billions of users, and a lot of them use Google products through speech. And as more speech is used, it's improving the system. And so if there's you know, a new politician that's popular in Australia, or a new topic in the news in Spain, if like Brexit is now an actual word that people use, or people are searching for Cardi B, all of these things we sort of understand automatically because we have you know, data that's fed by our users. And all of this technology was used to build our cloud products. So when we introduced cloud speech to text initially 3 years ago, it was built on this foundation, and that is powering all of the other cloud products. Now, as I mentioned before, it's important to understand this is a one-way arrow, right? So we do not use data from cloud customers to improve our consumer services unless a customer explicitly opts in. But typically it's not used, so it's only in that direction. But that helped us build a pretty unique speech experience that we now offer on the cloud, and you can very easily benefit from. So with that, we now have speech recognition in 120 plus languages and variants, which is pretty crazy. Like, I didn't even know there were so many languages in the world. It's available real-time, streaming in batch. And it performs really well in noisy environments because it's trained on data from noisy environments. So we have people in India that are talking to their phones while a bus is passing by. We have people in Times Square that are talking while there are a bunch of people around them. And it's built to work in that kind of environment. Our text-to-speech is the only production-scale cloud service out there with WaveNet speech synthesis. And you'll see in a little bit why that matters a lot. There's now 21 languages and more, and it works for text and SSML. So since our speech products were introduced 3 years ago, there's been a lot of innovation in this space. I'm not going to cover everything. There's a lot here, but you know, we improved accuracy. We made transcription much faster. We added automatic punctuation. You know, language auto detect. We're the only cloud service, as far as I know, that provides that. Word level confidence, word level timestamps, all of these things that our cloud customers told us that they need. And then the special thing about the product is it's built on our machine learning expertise. So I'll give you guys an anecdote. A few years ago, we realized that very soon, if we were to process speech in the scale that we want to do, we're going to run out of compute capacity. All of Google's data centers in the world are not going to be enough. And so we made this kind of future-looking bet of $10+ billion to build our own machine learning infrastructure with our, what we call our tensor processing units, TPUs. You know, that was done well ahead of the curve in the industry. We just exposed it to the world 2 years ago, but we've been using it for many years now to power all of our speech. And this is the only reason we can actually run speech at scale that no one else is doing. And then when we actually produce our models at Google, we for kind of we have the world a very renowned speech team that published a lot of the kind of important research papers in the field. But then when we run into kind of difficult problems, we can also get in touch with other machine learning experts at Google. So we have Google AI, which was formerly called Google Brain. We have DeepMind, and we frequently reach out to them and get advice from them on building things. And so WaveNet was done in collaboration with DeepMind, for example. A lot of the other things we do are in collaboration with Google Brain. So this is sort of what feeds the innovation at Google. Let me go back to presentation mode. So with all of that, last year we announced our new premium models. So originally, as I showed you guys, most of the models came from our consumer products. We were using in cloud the same models that we used for our consumer services. Last year, we introduced the premium models that were built especially for cloud. The phone call model, for example, shows 62% improvement. So this is 60% reduction in word error rate. You can claim it's 2x better than what existed before. And what we frequently heard from customers is that the model that existed before was already on par with the best in class in the industry. So we think the new model is quite differentiated in the space. A lot of customers come to us, as I mentioned earlier, and say, hey, I don't need the best accuracy, I just need something that's good enough to do the job that I need to do. You know, in the new use cases that you actually want to use speech for today, what used to be good enough accuracy is no longer good enough. So look at this conversation, for example, and imagine you need to play that bot as a human, and you need to answer this person that wants to order a Mexican burger with cheese, a large fries, and a Coke. You know, any human can do it, right? And you can develop pretty good bot technology that allows you to build a bot that does that. But then, what happens if you have 90% accuracy? 90% sounds pretty good, right? That means in that 40-word utterance, there's going to be 4 words that are wrong. It almost doesn't matter which 4 words. If you even ask a human to order 1 hexagon burger with a large fries and a coal, no one knows what to do with that, right? And then if the user needs to repeat again and it's more than 10 words, if at 90%, one of those is going to be wrong again. And the user is going to be frustrated because even when they repeat again, it's still not going to understand them, right? And most likely that user is either going to go to a human agent or they're going to hang up, and what you're going to see is low conversion rate. And then when you go to 80%, which is, you know, not unheard of at all in the industry if you have pretty noisy data with a lot of interference, it all breaks down. And so what we see is getting these high accuracy rates is really, really important to get sort of fulfillment, to get to build a voice bot that actually does kind of end-to-end what the customer is looking for. Okay, let's talk a little bit about text-to-speech. Traditionally in the industry, you guys know, a lot of you already know, concatenative and parametric were kind of the typical ways that people build text-to-speech. Concatenative stitches segments of recorded audio together to build a sentence. Parametric builds an algorithmic model of how human speech should sound like. And the problem with concatenative, it's very hard to collect data enough because you basically need you know, all the words that you would want to say. When you stitch it, it can sound artificial. Parametric sounds very robotic. if you use a combination of those, then you have the combination of those disadvantages. We introduced WaveNet to cloud last year. WaveNet runs on a large neural network, runs 24,000 times for every second of audio to generate audio to do speech synthesis, and it results in much better quality. The problem is, as you could imagine, 24,000 times of a very large neural network is really, really hard to run. And so that's why you can see it was really hard in the beginning. We spent some research effort. We were able, with the power of TPUs and parallel processing, we were able to make it run 1,000 times faster. And this is because we have this compute power at Google, right, where we can run a lot of TPUs together to generate one speech synthesis request that we need to do, which we're very fortunate to have. And the result is what you can see here. The quality difference is quite astounding. You can see on the left standard TTS, on the right human TTS, and these are mean opinion scores. And in the middle, it's WaveNet. So in the green one, you can see WaveNet is 3.98 versus the human is 4.11. So a big, almost it reaches the level of human. On the red one as well, you can see 4.22 versus 4.44. Overall, it closes 70% of the gap on average. Let's see a quick demo. Do you guys want to see a demo or not? Raise hands. Yes, okay. I just took from the news today this random article, and let's copy this paragraph here. And what I'm going to do is first I'm going to show you our standard text-to-speech. Okay.
In exchange, Berkshire Hathaway will receive 100,000 shares of cumulative perpetual preferred stock with a value of $100,000 per share. It will also get a warrant to purchase up to 80 million shares of Occidental common stock at $62.50 per share.
So this is actually pretty hard text to read out loud, right? It has a lot of financial terms. It's non-trivial. It has like all of these format descriptors. Because we needed to make it work for Google, we developed all this technology many years ago to sort of convert it to speech. Now the other thing worth noting, you could hear the sound was pretty easy to understand. You could understand every single word, but it did sound a little robotic, right? Now let's hear the same with WaveNet.
In exchange, Berkshire Hathaway will receive 100,000 shares of cumulative perpetual preferred stock with a value of $100,000 per share. It will also get a warrant to purchase up to 80 million shares of Occidental common stock at $62.50 per share.
So you can see, it's much easier to understand, much more pleasurable. We have companies like Ingram Media that are using it to actually even generate excerpts of audiobooks, which is pretty amazing. Okay. So that's kind of the core of the presentation, but we did want to leave you with kind of a couple small gifts. They're both from the last few weeks. One is speech analytics framework. So speech analytics in the call center is really, really difficult to do. It's really helpful, if you really want to understand what's going on there. A lot of companies are lacking that insight into being able to get speech analytics. But it's kind of hard to do, right? It requires usually an IT project. And we see a lot of enterprises sort of struggle with getting the budget or with getting approval from everyone that's needed to actually unlock the insights from their call center. And so what we're introducing is this speech analytics framework that lets you go from audio to analytics in less than 2 weeks. And we're delivering it with a set of SI partners that can help you build this out for your organization with your data with very low cost. Let's see a quick demo of how it looks like. Sorry. So here you can see, let's go to to the dashboard, you can see you have all these stats like average call sentiments, silence, call length. Things like call silence are really helpful. They let you understand, is the customer being put on hold a lot, right? And you can understand how much is the agent talking versus the client. All of these different stats that are really important. But then you can drill into a specific call, and in that specific call, you get the transcript. You can do things like analyze the entities in there, like what are the people that are mentioned, what are the consumer goods that are mentioned, any locations, Austin and New York. This is, by the way, is an example of a call to a call center for an airline operator. And then you have the diarized transcript where the agent and the customer are talking to each other. This is all diarized with machine learning. So it's never going to be perfect, but it gives you kind of an overall view of what they're saying to each other. Then on the top, we have this sentiment timeline. So you can see the call kind of started okay, but then things kind of went sideways a little bit before recovering at the end. And we can go into somewhere like here to kind of, maybe let's start with the beginning to hear the call context.
Hello, my name is Joe and I'll be assisting you today. Who am I speaking with?
This is Mary Cooper speaking.
How can I help you today, Mary?
I need to cancel a reservation.
Well, I'm happy to help.
Okay, now let's hear this point.
Fee. Should I go ahead?
That's incorrect. When I bought the ticket, I was told I can cancel any time with no penalty.
So this is actually pretty hard to understand negative sentiment from this sentence, right? But it was able to understand that it's red, and you can use these different insights to kind of have a better view into what's happening in your call center. If you're interested in more information, it's available on our website. It's called Visualize Speech Data with Speech Analysis Framework. There's a pretty long section that explains how to do it. And we're offering the source code behind the UI to all of our partners. Talk to us if you want to work on creating it, and we can help you do it. And then last thing, we want to show you this speech translation demo. So I've noticed there's a lot of demo videos I've seen in the conference so far. I've seen very few live speech demos. I understand why. It's like really hard, right? There's like always with speech demos, there's a chance that things won't go right. We're gonna take a risk here, even with the echo from all the mics and everything, and the background noise. Let's hope it works okay. Does anyone here speak a language that isn't English? German. Okay. Now the problem is I don't speak German, so I won't be able to know if this works or not. So you'll need to tell me. But hi everyone. I hope you've been enjoying the last 2 days at the conference.
Hallo allerseits. Ich hoffe, Sie haben die letzten 2 Tage der Konferenz genossen.
Did that work? Cool. Yeah, so clearly there's a lot of places where things can have errors, but it's a really helpful tool, especially when you're trying to understand someone that's speaking a different language, and you kind of need to bridge the gap, right? So even if it's not perfect, and even if it's not exactly the same as a native speaker would say it, as long as you can understand the meaning, you can get insight from it. Let me show you an example of how it can be used in the call center.
Hi, what can I help you with today?
Hola, ¿en qué puedo ayudarte hoy?
Let me just pause. So what you're seeing here is the agent was talking in English, and it translated what the agent said into Spanish. And then on the other side, you have a client. Now the client is talking Spanish. The agent doesn't hear what the client is saying. Instead, it will hear what Google is translating. So you can see the client is talking right now. You can see with that waveform.
Hi, I want to change my flight reservation from Madrid to New York on Wednesday.
Sure. What time would you like to leave New York?
So you can see the
Por supuesto. ¿A qué hora te gustaría irte a Nueva York?
the client actually said hola, quiero cambiar, whatever's in there. And it basically translated back to English so the agent can understand what
I
he's
want to
saying.
leave New York at 11.
I have a flight that leaves from JFK at 10.
Tengo un vuelo que sale de JFK a las 10.
Okay.
Perfect. How much does that flight cost?
I think you get
It's
the drift,
$100
but, basically, this could be used as a tool to bridge more languages. If you have 2 or 3 languages in your call center, you can add a lot more with something like this. So that's it for you guys today. Please stop by our booth. We're happy to answer any questions you have and help you kind of enjoy Google Cloud. I don't have business cards, but I put my email up there, so feel free to email me if anyone wants to follow up or ask questions. So that's it. Thank you very much.